Hello everyone, we are starting a free open lecture in our Discord. All our lectures are held weekly, without interruptions. If you, the viewer, want to ask questions and get answers in an online format, join our lectures. The link to Discord can be found in our Telegram channel. To find out the schedule of the lectures, join our Telegram channel. Yes, for each position of the IZH, we will have two states of conditions, all possible ones for the profile, TFSP. You're talking about this, right? Yes, 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 and each subsequent mask will remember that it just appeared, but not all the positions that we need. So, what is here? It will remember, but what we have saved here, it won't remember anymore. Well, it's clear. It will only remember where it needs to, like to calculate the next position. Yes. Understood.
Want to become a great programmer? Subscribe to our Telegram channel.
So, rectangles. In this scenario, the mask will appear somewhat unusual. We are presented with a field once more, along with a large pit that stands out prominently, in which some cells are cut out, creating gaps or empty spaces. It is required to fill these free cells with the minimum number of rectangles, ensuring that the solution is efficient and optimal. That is, we have some unfilled cells that need to be filled with the smallest number of rectangles in order to appropriately and correctly complete the task. That is, for this arrangement, we can do it like this. Here are two large ones, and here is one small one. Placing a piece here is the same as what was here with the big and small ones. Here, there is a thick long one, and essentially, it shows how this is done. In this situation, it can be done in different ways. For example, you can shorten this one, or lengthen that one. Still, the optimal number here is a maximum of 7. It cannot be filled with a smaller number. Well, accordingly, to solve this, a straight profile will be required. What does this mean if we have it here? We had a broken profile, meaning that half of the profile stored some value for this row and half for the next one. Well, not exactly half. It was part from here and part from there. Here, however, we have a direct profile, which means we store information only for the current row in its entirety. And it is only information that is needed for it. Accordingly, how could we write some current row? Here we have two rectangles, one measuring 1 by 2 and the other 1 by 4. This could be written using coordinates like x, y, 0, 2, and 3, 4, where x represents the coordinates from where we start the rectangle, and y is the length of the rectangle. So we have coordinates 0 with a length of 2, meaning 0 and 1 fill the length of 2. Then we have a rectangle starting at 3 and extending to 4, which corresponds to 1, 2, 3, 4 in length. Additionally, we can also store information about whether the rectangle starts in this row or if it is a continuation of an existing one that was started earlier. Well, there is actually an example here, that is, if our rectangle is continuing, what situation might we have? If a new one starts, we have a show of 3, TFSP. Yes, 3, which includes 5 coordinates. A new one starts here, and it will be 1 cell longer. If in the previous line x and y match the current ones, then the rectangle continues. We need to verify this. How exactly can we go about filling in all the necessary information regarding rectangles in a comprehensive manner? This can be done using a bit mask, where a 1 indicates that a new rectangle is starting at this position, and a 0 indicates that slightly. We actually had a rectangle before in this row, where there is a cutout cell at all. That is, this is basically how you can essentially write such a matrix in, let's consider this cell. So what does this one mean? It means that in this row, specifically in the cell with a gradient of exactly 0, a rectangle begins, and then we have the following. It means that a rectangle is also starting here, and one more one, the third. It means that this is essentially how the rectangle is. The apparatus in zeros means that, for example, here, this is equivalent to the rectangle continuing. And this 0 means that here we are simply storing it this way. The starting cell from where the rectangle begins. In this case, we will not need to store the value of the length of this rectangle because we will simply manage until the next start or until a punched cell appears, TFSP. Thus, the essence of the solution will be in iterating through all masks for the row and selecting the optimal value. That is to say, by the way, this mask should be suitable for this row under 40, meaning that here we could have placed some mask. But if we place a 0 here, it does not fit for this row because a rectangle will start here anyway. If we place 0 right over there, then it won't work. Also, in fact, the mask can fit different rows. Actually, meaning that there could have been a continuation of this rectangle right over here, and it would still be valid. So, the task will be to find the minimum number of rectangles that can fill the first row, where this row is described with the current mask. This means we need to carefully analyze the mask to determine the optimal placement of rectangles. The goal is to ensure the row is completely filled with the least number of rectangles possible. If the mask is not suitable for the given row, then this specific state is equal to infinity. It is an unreachable condition. Well, when transitioning from one row to another, we need to understand how many new rectangles we will essentially have to create. For example, right here. When transitioning from this row to the next, we will have a new rectangle, meaning there will be one more. We need to understand how many new ones will appear in order to properly and accurately TFSP. Therefore, when transitioning from one row to another, an array of rectangles will be created, where the length of the rectangle will be stored in this cell, starting from this cell. What does this mean? It means that we will have an array that initially contains zeros and ones initially. If we reach the end of a rectangle, we save the length of the rectangle in place of that one. This will be 4. 2 will be inscribed here, 1 will be inscribed here, and exactly, precisely, when moving to a new row, we will very thoroughly check to ensure if our masks match exactly like this, properly. Whether there are rectangles or not, if they match, it essentially means we do not add a new rectangle to the result. If they do not match, but the bit masks fit together, we basically look at where new rectangles will appear, how many there will be, and so on. And here is an example specifically for filling how a sheet will be filled with such a row. That is, in position 0 we will store the number 2, and in position 3 there will be the number 4, specifically for these two rectangles. Yes, this array will definitely be calculated for the current row with the given mask. Then, all possible masks of the previous row will be thoroughly examined. And we will consider the cost of transitioning from the first row to this row with a given mask. That's how it will be. TFSP? Well, and accordingly, the recursive formula is initially infinite and unbounded, except for position 0.0. Here it will simply be 0 free of charge. If the transition cost, which represents the difficulty of changing from one state to another, is infinity, then the given mask, which is a specific pattern or template, does not fit this cell. In such a case, we move on to the next one. Otherwise, we calculate the minimum value required for the transition. We are calculating the transition price from the mask prev and the row specifically with 1 to our new row and with the mask, and accordingly, the size in memory will be n. This process involves determining the cost associated with moving from one state to another, taking into account the previous mask and the specific row marked with 1. The new row is then evaluated with the current mask, and the memory size is adjusted accordingly to ensure it fits within the constraints of n. Plus 1 multiplied by 2 to the power of n plus 1. By the way, that's incorrect. There's also a multiplication by... You need to multiply by n plus 1. Of course, you can store all of this in one row, but as far as I remember, it is not all stored in one row, but in several. Therefore, this way will be more correct. We will need an additional buffer row to break based on the lengths of rectangles, meaning we will proceed like this. We will save the start here, and as we go along, if we don't have TFSP empty cells here, we won't start saving what the number 4 will be. We will just save here, and that something was initiated here, but how much was initiated, who knows. That's why we put this thing here, and if we encounter a certain point, we save the length of the rectangle.
Want to become a great programmer? Subscribe to our Telegram channel.